Hey, how's it going everyone? Welcome to this video. In this section we're going to have a look at some of the worked examples from 9.3. So the first one's example 5 and we've got converting 30 degrees to radian measure. So first step, if we remember from our notes, to convert from Ds to radians we multiply by pi over 180. So all we need to do is take our 30 degrees, multiply it by pi over 180, and essentially we'll get 30 pi over 180, and we can do some cancellation here. 30 and 30 is a common multiple, so we'll get 1 over, that'll be 6, so it'll be 1 over 6 pi, or simply just pi on 6. And the next question says to convert 4 pi on 3 radians to degrees. And to do that, we simply multiply it by 180 over pi this time. So if we do that, we have 4 pi over 3 times 180 over pi. As you can see, the pi's will cancel. And we also have a common factor of 3 in both of those. And so we should get 240 when we get that. This one split up into two parts, so convert pi on 4 to degrees. So do that first, pi on 4, and we need to multiply it by 180 over pi. Pi's will cancel, and we get 180 over 4. And if we work that out, we'll get 45 degrees. And it says to use the value we get for pi on 4 to work out what sine of pi on 4 is. Well, pi on 4 we just worked out is 45 degrees. And if you remember from chapter 9.2, sine of 45 is going to be root 2 on 2. So that's either by using your exact values or the table that we made. Example 6, we've got -3 radians and we want to convert it to degrees. Again, we've got -3, need to multiply it by pi on 180, which is just -3 pi on 180. If we work that out, it's roughly minus 171.9, so that's just using our calculator. Degrees. Second part of the question says, well, first thing, draw a unit circle. Okay, and show the position -3 is mapped to when the real number line is wrapped around the circumference. So what we're saying is, we've got the number line starting at 0, and we've got -3, -2, -1. When we take this point here and place it on there, and then we wrap that line around, and we should get about -3 there, -2 there, -1 there, or thereabouts. Okay, and what we've got is this angle in here is going to be our -171.9. Example 7, we've got an arc subtending an angle 56 degrees at the center of a circle, radius 10 centimeters. calculate the length of an arc. So starting off with, our angle is 56 degrees. Converting that into radians, multiply that by pi on 180, will be 14 pi over 45. Our length is going to be our radius times our theta. We've got a radius of 10, and we've just worked out 14 pi on 45. So L is going to be 10 times 14 pi over 45. And if we work that out, it's roughly 9.77. So the arc length is 9.77 centimeters. And the second part says calculate the magnitude of the angle that an arc length 20 pi subtends at the center of a circle radius 15. So again, we've got L is R times theta. Our radius is 20 pi. Our length we know is radius of 15, length of 20 pi. So radius is 15 times our angle, and that's what we want to work out. So if we solve for our angle, we'll have 20 pi over 15, which is going to be 4 pi over 3. So the angle is 4 pi over 3. Just need to convert that to degrees. Oops. 4 pi over 3 times 180 over pi to get our degree, and we'll get 240 degrees for that. So the magnitude of the angle is 240 degrees. So that's it for 9.3. Thanks for watching.